Good evening and welcome to another Unreal tutorial. So, in this video, we will be cleaning up the enemies. Now, I imagine by this point you're all blueprinting pros, so I think what we're going to do is we are going to try and get through all of the enemies in a single video. We kind of got the groundworks for most of them anyway, so it's just going to be a bit of cleanup really. So if we go to the enemies folder, I'm going to go to the enemy base first of all, and I think what I want to do is in the event graph, I'm going to follow along with the original version of this that I've made, and I'm going to have the base enemy and the boss enemy both attack when they're in range of the player. So this is going to go in the base mode just so that we only have to do this once, and then if we did want to make this unique for different enemies that you include, I'm also going to show you how we can override this. So to begin with, off of the event tick, we already have this function here, which is really just setting up the movement. So in fact, we can come down here, and if we give this a comment just to say movement. So off of here then, this is where we will add the firing logic. First thing we want to do is, I said we're going to do this if we're in range of the player. So we're going to do an isValid check. We'll check if the player is actually valid, so whether it exists in the game basically. So we'll do this by getting a get player pawn node. So we'll check if the player pawn is currently in existence. This just makes sure that we haven't accidentally deleted the main pawn or it hasn't been spawned at all. If that's true, we're going to add a brief delay, as we don't want to do this constantly, and this will make it look a little bit more intelligent as well. And off of here, we're just going to add in a random float in range. So this is what will obviously be completely faking it, but it will make it look a little bit like the enemy is kind of timing when it wants to shoot. So then back off of the get player pawn, we can now get the actor location, so find out where it is in the world. And we've done something very similar to this before, so we want to do a vector minus a vector from this, and we'll get our current location. So we're just getting the distance between ourselves and the pawn. We'll do that with the get actor location node. Okay, so off of here we then want to get a vector times a vector, so multiplied by a vector, and we'll just do that by 1 on the x-axis, because we're only going to be searching from left to right, so we want to make sure that the player's in front of us basically. And to finish this off, we want to get the vector length, and this is really just turning this into a float value for us, because this is going to be more important for the check we do in a moment. So assuming that this is still correct, we actually want to do this isValid check again, and this is really just a double safety thing. It's not very expensive, of course, so it doesn't really matter, and it's just making sure that in between this random delay that we add, that the player ship hasn't been destroyed or, again, randomly disappeared somehow. So if that's still true, then we want to do a branch check, and from the branch check, we want to check whether or not this float value that we have is less than or equal to something. So do a less than or equal to float, and we're just going to plug that in there. And remember that we created this variable a little bit earlier on, the distance from player. We're now going to plug this back in here. I say a little bit, this is right at the beginning of the series, but this is the distance that we want to check we are away from the player before we fire. We're going to make that 120 units. Remember, we've already set that. So basically on the x-axis, if the player is within 120 units from where we are on the x-axis, then that is a valid range to begin firing. So that gives a little bit of offset for the projectile to travel up the screen and hit the player, because obviously if we make it too narrow, then we're always going to miss anyway, or the enemy's always going to miss anyway. Now, assuming all of this is correct, we're going to pull off of the branch and we will spawn an actor. So we'll do the spawn actor from class, and the class we want is going to be our projectile type. And in fact, I think we need to go and make that. So if we go back to the main window and go to our projectiles folder, note we have our BP underscore projectile enemy base and enemy 1 and enemy 2, so perfect. So what we can do is we can find the BP underscore projectile enemy base is what we want this to be. And to make this slightly more dynamic, we're going to choose the base class, we'll then right click on this and promote this to variable, and we'll call this the projectile type. Okay, so now we've got the type of projectile, and we can obviously set this up on each of the subclasses, and they can pass in their own type of projectile. So if we compile that, the next thing we want to do is to get the actor transform. Otherwise we're going to get this error here. And then we need to compile this, and this should reveal a few extra details. For some reason that hasn't happened. So, okay, so just make sure that the projectile type hasn't reverted itself to an actor. So again, we'll get the BP underscore projectile enemy base. And when you're doing this, make sure that you're selecting the class reference. So we'll change the variable, that's fine. And then if we try and hit compile again, this still isn't doing quite what I expected. So before we fix this, we're going to go and change the collision handling to always spawn and ignore collisions. Just make sure we've got the right thing there. And what we should be seeing over here are a few extra properties that maybe we haven't created yet. So if we go back to the projectile enemy base, there we go. So we want to set the projectile color on spawn. So we need to make this visible, and then we're going to go over to expose on spawn and compile that, save. And then if we now recompile again, okay, so I actually needed to alt click on that to delink that and then hook this back up. And now we have the projectile color reappearing, which is what we needed. That was the important thing. So we can then promote this to variable as well, and we'll just call this the projectile color, and we'll pass that down there. And again, we're going to have to come back a bit later and update this, but we'll get this ready for when we do have some sound effects ready. So we're going to play sound at location, and we'll just get the current location of the enemy. So we'll do a get actor location, and we'll play some form of shooting sound effect. And that should really be the firing function all set up. So now what we're going to do, unfortunately we cannot collapse this to a function because we have a delay in here. Unfortunately in the Unreal Engine, functions cannot have delays. So if we try to do this, we can grab everything, collapse that to function, and you'll see that we get an error. If you wanted to keep this tidier, we can collapse this into either nodes or a macro. Probably best off as nodes. And we can just call this the fire node, just so we know what it is. Now, kind of similar to a function, the only difference is we cannot call fire node. So in the same way we can call events and functions, we wouldn't be able to come in here and say do fire node. All this is really, it just tidies the blueprints up. We can click into this and then we can see what's happening here. So I'm going to choose that option just to keep the blueprints slightly smaller, and then go back to the event graph from there. So we have a fire node. So when we want to come and update the firing functionality, we know that it should be in here. So with that done, we'll go back to the main window again. We'll go back to the enemies, and first of all, we're going to go to enemy 1. We'll open this up, and we'll start giving this some of the properties that we need. So the projectile color, I'm going to get to match the enemy. I don't think we've given the enemy a material yet. So for element 0, I'll just make this the black body that I've given pretty much everything else, and we will make the armor pieces the kind of orange color, which is being used for the projectiles too. So that will be our first enemy. I'm going to give it the projectile color, a similar color to match its body. So we'll come down here and we'll give this a kind of reddish orange color, make it quite bright. So this is what will be passed in when the enemy 1 type of enemy fires. And also remember that we've got a projectile type to pass in as well, and we want to give that the projectile enemy 1. So with that done, we can go back out, save that, and then go into enemy 2. Do a similar thing. We'll go to the static mesh first of all. This time I think I'm just going to invert the colours. So I'll give this the glow projectile colour, this time for the armour, so it definitely looks a little bit different, and we'll know that we'll be fighting something slightly off. And we'll just give that the dark body colour. And then if we select the BP_enemy2 again so that we can change the projectile colour. So we're going to give the projectile colour, we'll make this a kind of light bluish turquoise colour. Again, just so that we know that when the different projectiles are flying up and down the screen, we can tell where they're coming from. And the projectile type, we don't actually have one for enemy 2. If you wanted to, you can, but I'm only really working with the cubes, so they're going to look the same anyway. That's just kind of setting up the possibility for you to have different projectiles if you wanted. So now if we press play, we should have the standard enemy types coming in. So we've got the color, and that one's bouncing backwards and forwards. Okay, so I think what was happening there is if we go to our projectiles, we go to the projectile enemy base, and just realised I did have the projectile enemy too, so I'll just double check the class that this has. It should be a parent class of the enemy base. So if we go back to enemy 2, we should actually be able to use that. Okay, that was strange, it wasn't showing, but it seems that opening up the blueprint has revealed that to enemy 2. So we do have a projectile just for enemy 2, so we'll use that one. But back in the projectile base class, I think what we have happening is when this is colliding, you can see that the enemies are just bouncing back and forward. It looks as though they're shooting, and this is set to block all. So we want this to be custom, and we don't want it to hit the enemy type. So we're going to ignore the enemy type, so we're not making any collision checks. I think what was happening is the projectiles were hitting the enemies, and that was firing off this check. So the event hit, which is obviously then flipping the movement direction, I think. So if we go back in and play now, this should not do that. There we go, and they're firing. Perfect. So that is a step in the right direction, and then we should see, yeah, so the boss is firing different coloured projectiles. Perfect, so that is all working as expected. So I'm going to close all other tabs apart from the main tab for now. I'm going to go into the enemy Asteroid this time, and this is where it's going to get a little bit different. So the first thing we're going to do is we are just going to remove the event tick. So by removing the event tick, that means we're not having the parent call anymore. So that is going to override the default function for moving side to side and also trying to fire. So that's the first thing we want to do. We're also going to get rid of the things which are set up on the event begin play, and we're going to do our very own custom logic in this Asteroid class. So on event begin play, first thing we need is the game mode again. Okay, so we're going to get our game mode, and we will get the, and we're going to do that the way we've always done that. So we're going to get the game mode off of the object pin. When that returns, we want to promote that to a variable, and we will call that the BP_game mode. So off of the asBP pin, we've already got the reference to this in our parent class, so we'll get set the BP_game mode to be what we've just cast to there. And quite simply on this one, we have our move speed. So we want to set our move speed first of all, and we'll just randomize this. So we'll get a random float in range. And then what we want to do is we already have our minimum and maximum values as well. So we'll get min speed and get max speed, and we'll just plug these into the respective slots. And we can change this a little bit. We want this to go down a little bit faster. So the minimum I'll set to 100, and the maximum we'll set to 250 should be fine actually. But we just want the minimum to at least be higher. And then from here we can also set the maximum speed to be whatever this random float has returned. Now the next thing we want to do is we're going to add a new component, and this will be a projectile movement. We're going to control drag the projectile movement in, and from here we want to set the maximum speed of this. And that will be the value that we've just returned from our random variable. And then we also want to set the initial speed. And again, we can just set that to be the same value. So we're not going to have any momentum or anything picking up here. It's just going to go at a constant speed down the screen. And finally, last two things, we want to set the scale of the object. Set scale, which is this variable that we've made over here. We'll do this by using a make vector, and as you know that I love randomness, we're going to use a random float in range, just so that every asteroid isn't the same size, and we'll plug this into each of the axes, and we'll get a minimum and a maximum scale. So I'm going to pre-fill these values. We'll make the minimum 3 and the maximum 6. We'll promote that to variable, and we'll call this min scale, and then we'll promote the maximum to a variable, and we'll call that max scale. Reason we're doing that, just in case I've not mentioned it before, though I think I have, if we hit compile, if we look at these, because we've pre-filled these slots, the value will actually take the same value that we had in the slot that we filled. So we've got the minimum and maximum of 3 and 6. And then finally off of here, we can just drag off of the value, and we can find the set world scale value. And it knows that the only thing we can do this to will be the static mesh. So we'll set the world scale of the static mesh. That will be the random value we've just made. And that is pretty much just done. So if we hit play now, we should see that the asteroids will be falling straight down the screen, and they will not try to fire. If I don't shoot, they won't die. And we do need to go back, it looks as though we need to go back and update the health values for the different ships. And I believe that the projectile movement, we need to set the velocity to the right direction. So we don't want this to go sideways. X is obviously sideways, and the velocity at the moment, we're just moving the, remember, we're moving the projectile on the using the speed. So that was setting that to go whichever direction, 100 to 250 on the positive x-axis. What we want this to actually do is go on the negative z-axis, which would be down the screen. That's why we weren't seeing the asteroid, I believe. So if we go back in now, we should hopefully see some asteroids coming down the screen. And just go back out and debug this and see what's happening. So if we hit F8, so they're spawning, but they are not moving. So we'll find out why. In fact, I already know why. If we go to the static mesh, I think we need to change the collision on this one. So if we set this to ignore everything, apart from, we want it to overlap the pool. And I think because we have the fake wall at the top to stop the player from moving past, I think it's hitting that. There we go. So yeah, it was hitting the fake wall, and that was stopping it from having any movement enabled on the projectile. So that was a nice simple fix. Still going to work. It means that it's going to ignore the... it does mean it won't be hit by the projectile, which I think we gave the collision type of vehicle. So if we go back in and also make it block the vehicle type as well, we'll then go and hit play one more time. And there we go. So yeah, we can now blow those up. So make sure that we have the collision set to block the pawn and the vehicle and ignore everything else. And that means it'll be able to move down the screen. And the very, very final thing. Now this is quite important because I didn't really factor this in when I was making the original enemy types, that the asteroids would be counting towards the enemy count when you kill them. And I didn't want that to be a case. I kind of wanted them to be a constant enemy. So you could kill like 100 or 1,000 different asteroids, and that wouldn't count towards spawning the boss because they're not very troublesome. They're just kind of a few extra points just for the sake of having them there. So what I'm going to do is I'm actually going to override the function, which was the enemy killed function. So this is going to show as an event because for some reason when you override a function inside of the Unreal Engine, the override needs to be done as an event. But if we double click into this, this will take us to our function we've created in the base class. And this is normally what happens when we're killing an enemy, is we're going to tell the game mode that we've killed an enemy, change the score, and it's this function here that we want to override so that we're not adding to the enemy killed count. So back in our asteroid, we want to simply get the game modes. So that would just get the BP_game mode, and all we want to do this time is control the score. So we're going to do the set score function. Set that to be the enemy score value that we give the asteroids. So remember, all of these are coming from the parent class. These are all inherited variables. Same again, we want to play our camera shake on the game mode. The epicenter is just going to be the location of this enemy. We do our play sound at location, and we can use this again. And then finally we want to destroy the actor. So in fact, we'll just double check before we do this. We'll just double check that this is working, that we've done this override correctly. So if we go back in, wait for an asteroid to come down, and we'll try and blow it up. So we can see that the asteroid isn't going anywhere. So now, just to make sure that this is working, we can destroy the actor, and this time we'll see if we can find an asteroid. And there we go. So now we've got our new function happening. We're adding the score, but we are not taking away from the enemy kill count. And after doing the original setup and realizing that that would be a problem, I thought this would be a really, really good example to show you. We've seen a lot of overriding in this video. So we've overridden the parent call to the event tick so that we're not doing the same movement for the asteroid. We've also overridden the event begin play, and we're doing our own cast in this class. And then we've been able to override a function as well, so that when the enemy is killed, we have different logic going on. Now you may start asking at this stage, we're doing so many overrides, is it worth still having this being a inherited class? And I would say that it probably is, just because it means that we can still use mostly the same collision setup. We can still class it as an enemy, we can still have all of the inherited variables that we're using, we've still got the enemy score, the speeds, and things like that. So I think inheritance is still useful here. But obviously you need that freedom to be able to override the logic and the function and event calls. So I think this is a really good way to demonstrate that. So it's quite a unique class, it has different moves and it has the different logic, but it can still be a derivative of the enemy base. So there we go, as I said, in one video, slightly longer than usual, we now have all of the enemy stuff set up and ready to go, which brings us that one step closer to getting the polish into the game, the sound effects and the camera shake and things like that. So I'll leave that one here today. As always though, if you've enjoyed this or found it useful, then please do leave a like and share the video around. If you'd like to be kept up to date with the latest content on the channel, then go ahead and subscribe. And as ever, thanks for watching, and I'll see you all next time.